All right, welcome to lesson 13.1. We're going to solve our systems by graphing first. So our objective is that I can solve systems of linear equations by graphing them. Okay, so a system of linear equations is a set of two equations that we solve together to find the solution. The solution in this case is where the two graphs cross each other. So where the lines are going to meet, that is the solution, the single point that they meet. Or if they totally overlap, it could be all of the points. Or if they're parallel, it could be none of the points. There could be zero solution. So just like we did in the pre-module review, we're going to graph in the same way. So here's our first example. We've got this equation, we've got this equation. We're going to find the y-intercept and the slope. We're going to graph them by plotting our y-intercept, traveling our slope, and drawing our line. All right, so here's our first equation. Remember, our y-intercept is going to be this guy, the plus or minus at the end. And our slope is going to be the number in front of x. Notice here there is no number. If there's no number in front of x, that means our slope is going to be 1. There's an invisible 1 there. So slope is 1, which means our rise is 1 and our run is 1. Our slope in the second equation is -2. Which means we're going to go down 2 for every 1. So our rise is -2 and our run is 1. In our first equation, our y-intercept is 1, and our y-intercept in the second equation is 4. All right, the first thing we're going to do is plot our y-intercept for our first equation. So our y-intercept here is 1, so I'm going to go over here, and I'm going to go up to 1 on our y-axis. Now I'm going to go our slope. Our slope is 1 over 1, which means I go over 1, up 1, over, up, over, up, over, up. You don't need to plot every single point. You can use, let's see if I have a ruler. You can use a ruler, you can use a binder, you can use something that's got kind of a straight edge and line it up with your points. You can just kind of zoop. There's our line. That's not bad. So there is equation number 1, and you could label it if you want, y equals x plus 1. Let's plot our second equation. So all of these points on this line, every little bit of this line is a solution to equation number 1. Let's find solutions for equation number 2. Our y-intercept is 4, so I'm going to go over to our 0 here. I'm going to go up to 4 on our y-axis and put a dot. Now I'm going to go our slope. Our slope is -2, which means that if I go over 1, if I run 1, I have to go down 2. There's my second point. I can use my ruler. And here's my second equation. Y equals -2x plus 4. So everything on this line is a solution to our second equation. Now, the important thing is right here. This is our solution to both equations. This is the one point where both of the equations are true at the same time. We need to know the values there. For our solution, we're going to write it as a coordinate, which means we're going to put our x number first. Our x number is the horizontal, and our y number second. So here's our point. The x value is right here. It's between 0 and 2, which is going to be 1. Our y value is right here. It's +2. So our solution, where these two equations meet, is over 1, up 2. That's the only values that we can plug into both equations to make them true. All right, let's look at one more. Okay, here we have our first equation, y equals x minus 2, and our second equation, y equals 3x. Let's find our y-intercept first. The first one is -2. The second one, you'll notice there's nothing over there, which means our y-intercept is just going to be 0. And I didn't highlight that in blue. If there is no y-intercept, if there is no plus or minus at the end, our y-intercept is going to be 0. All right, next we need our slope. Again, our first equation doesn't have a slope. There's no number in front of it, which means it's an invisible 1. So our slope is 1, which means our rise of 1, run of 1. Our second equation, our slope is 3, which means we rise 3 and run 1. Now, it's been a minute since we talked about rise over run as slope. Now that we've identified our pieces, we can go ahead and graph them. The first thing we need to do is plot our y-intercept for the first equation. So here's our y-intercept is -2. Remember, your y-axis is the vertical one, the one that goes up and down. So I'm going to go over to 0, and I'm going to go down to -2, and there's our y-intercept. Then we do our slope. Our slope is 1, which means I'm going to go over 1, up 1. Boop. There's my second point. And now I'm going to connect my 2 points. Here's my first line. I'm going to go ahead and label it y equals x minus 2. And now we're going to do the same thing with our second point. Our y-intercept is 0. So I'm going to put it right in the middle at the origin, because that's where 0 is. Our slope is 3, which means I'm going to go up 3. Or I'm going to go over 1, up 3. And now I'm going to go ahead and take that and graph those points. Alrighty, there we go, and this is my second line, y equals 3x, and here is my intersection. Notice it's a little bit off the point because my line is imperfect, but it's close enough. Here is our point. Our x value is -2, and our y value is -4. At -2, -4 is where both of these equations are true at the same time. So if y is -4, oh, this should be -1, -3. Actually, I messed that up. I drew my line incorrectly. This is the intersection right here at -1, -3. My bad. Here's how I know that this is not true, that our original point was not true. -4 as our y value equals 3 times -2. 3 times -2 is -6, so this is not true. But if we plug in -3 equals 3 times -1, 3 times -1 is -3, so that is true. If we plug in these values here, so y equals -3 equals -1 minus 2. -1 minus 2 does give us -3, so this is true for both equations. You're going to go ahead and dive into your practice. Let me know if you have questions.